These examples, I think, have illustrated that the design of anything depends not only on what it's doing or what it's being used for, but where it's being used. Now, you may remember that at the beginning of the programme, I said that one of the main reasons something needs a structure is to prevent it from collapsing or falling down. And the first question we have to ask ourselves is, what could cause a bridge or a building or anything for that matter to fall down in the first place? Well, here on Earth, we're constantly fighting gravity, holding up our own weight, for instance, or this house of cards. And we also have to do battle with the wind. And a building has to do exactly the same. In fact, there are a lot of forces that push, pull, bend and twist our buildings. They come from what we call the loads on a structure. There is always a war going on between the loads that are trying to tear the building down and the structure we've designed to hold it all up. Two kinds of loads force themselves on a building: dead loads and live loads. Let's deal with dead loads first. They are permanent and don't change. The weight of the building itself is the best and perhaps most important example. A building has to hold up its own weight. So what we make a building out of can be very important. For example, in beams of equal size, steel will weigh 3 times as much as concrete. Surprisingly, aluminum weighs slightly more than concrete. Now, I know that may seem difficult to believe, but it's true, because we never see something made out of aluminum the same size as we do concrete. Glass weighs about the same as concrete, but wood will weigh just 1/16 as much as steel. Is it any wonder then that we still use wood for many different kinds of structures? In fact, with many modern man-made building materials, the designers have tried and are still trying to mimic the properties of wood. Of course, we can look up information like this in a book, and that would tell us how much our structure weighs. So that would take care of the dead loads. But we also have to cope with live loads, and they can be much trickier to deal with. You see, they are the non-permanent loads, the changeable ones. They are the ones we have to make a best guess at, and we better be sure that our best guess is a good one. If we underestimate the live load, our building might fall down. If we're overly conservative, the building might be too expensive to put up in the first place. Every design has to take into account these competing concerns. So what are the live loads? Well, that's easy. Anything that moves or changes. The people in a building, its furniture, and even the dividing walls and movable partitions. And the same applies to cars and trucks on a bridge. Well, those are fairly